In this video, I'm going to be working some modeling problems and talking a lot about residuals. Okay, so we are going to start off by looking at a data set that is practically linear. Okay, the average rate of change is almost consistently 3. And we're going to run a linear and an exponential regression. And oh, it already was run, and they calculated the residuals for us. That's nice because it's really kind of a painstaking process. We're going to plot the residuals and show the visualization of a good regression model and a bad regression model. Alright, so I'm going to go pretty quick on this and not be too fine with it, but I'm going to change the scale on this one because I'm not seeing anything even close to 1. So I'm going to make this 0.5. Is there anything? It's a little bit bigger than 0.5. I'm going to go with that, and this is going to be negative 0.4. Is there anything negative down there? No. Okay, yeah, so I'm going to need to change that scale, otherwise those are going to be... They were all going to be close to 0 and be like, I can't see if there's a pattern or not. So, negative 0.2, that's at 1. Then negative 0.04, about there. Negative 0.3. Positive 0.25. Positive 0.54. Positive 0.34. This doesn't really look like a pattern here. Positive 0.13, negative 0.5, didn't see that one, but I'm just going to say that's about there. Negative 0.07 and negative 0.08. Something like that. Okay, and this is pretty random scatter around the x-axis, so I'm going to say that's probably the appropriate model. Okay, if I go over here and I look at the exponential regression, but the thing is that like I know that whoever made this homework, he ran the regression, and actually this is an actual model, and so we're going to see a real pattern here, and not just something we made up in a table. So 1 and negative 4.4. Okay. Scale of these is a little frustrating. Negative 2.4, negative 1.1, positive 0.7. Oh, yeah, I'm seeing kind of a pattern here. Positive 1.9, positive 2.2, 2.0, 0.9, 0.1, and negative 2.1. Yep, it's that up then down. You can't really see that. Let's see if I can make sure more of this is visible. Yeah, there you go. Because that really even hammered it home more that we're seeing an up then down pattern, so it's definitely a linear data set. Oh, but we actually already knew that. That's what I told you from the beginning. Okay, now I'm kind of seeing the point of the example. Okay, now number 2. Here we've got a table. The number of cars in the United States grew exponentially after Mr. Ford utilized the assembly line process to manufacture cars. That's definitely true. Table above gives data for the total number of cars in the U.S. per 1,000 people for several years between 1920 and 1980. Okay, so we're going to do an exponential model, and then we're going to predict for the year 1935, and then lastly find the residual for the number of cars that, based on what we predict. Oh no, for the year 1980. Okay, so but we have the actual number. Okay, so it's time. Got to go into the calculator, get into the lists, edit. Okay, I'm going to type in 0, 10, 20, 30, 40, 50, and 60. Then 86.78. 217.34, 323.71, 410.37, 545.35, and 710.21. What just happened here? Did I miss one? 0, 10, 20, 30, 40, 50, 60. Oh, goodness. Okay. I missed the one that was 245. Okay, maybe I can insert one. Oh, that's great. 245, 63. That's nice. Okay, 323.71 goes with 30. 410.37 goes with 40. 10 is with 217. Okay, yeah, I feel good about this. Okay, because if we type it in wrong, there's really nothing we can do. Kind of in trouble. So go up here. Exponential regression is option 0. We're going to need to reason with this a little bit, so I'm going to store that into y1, and then I'm going to calculate. Okay, so I'm going to, in that, that'll be, my model is y hat equals a 120.091 times b to the x, 1.031 to the x. And according to the model, how many cars were in the U.S. per 1,000 people in the year 1935? Okay, so it's number of years since 1920. I'm going to plug in t equals 15. And to call for y1. I could do that from the F4 menu, or I could do it from variables. I'll do that definitely on this video at some point. 15, plug that in, and get 190.980 or 979. 190.980. Okay. Find the residual for the number of cars in the U.S. per 1,000 people for the year 1980. Well, that's going to be actual minus predicted. That's what residual is. And so actual was 710.21, because that was 60 years after 1920, minus the predicted, and that's going to be y hat of 60. And I'm going to just have the calculator do that. Okay, so that's going to be 710.21 minus, the variables, y variables, I'm in function mode, y1 of 60. If I had to do that, that would be negative 57.880. Negative 57.880. Okay, let's do that. Now we've got another one. Another table. We're going to use the regression capabilities, linear model. Okay, of the form y equals a plus bx. Okay, well, our calculator can do that for us. So we'll go over here, back to the menu. I'm going to edit my lists. I'm going to clear them out and type in my data. Oh, if I'd only noticed the same x values. Okay, 2.5, 3.02, 3.7, 4.44, 5.32, 6.15, and 784. Again, I missed one. 302, 37, 444, 532, 615, 699, and 784. Okay, there we go. So we are going to run a regression. A plus bx was what was requested, so I can ask for option 8. This 1, this 2. It's still stored in y1 because I'm sure we're going to be doing some predictions, and then we're going to calculate. Okay, then I'm going to get y hat equals a 2.2675. If it's just one more decimal, that's the harm. Plus bx. For this one, we're going to have to round off to 3 decimals, 0.078 times x. Okay, what was the world population in 79? Okay, years since 1950. That would be 29 years after 1950, so y hat of 29 is going to be equal to, you don't need to show the, especially if you've already written the equation right there, you don't need to show that you're plugging in 29. It's implied by the fact that you write y hat of 29, so y1 of 29 is going to equal 4.527 billion. So 4.527 billion. And what is the residual of the total world population for the year 1990? That would be 40 years after 1950. So I'm going to do the same thing. I might actually just call for the same command and then scroll back over there and write over that with years after 1950, 40. Right, and then I get 5 point, okay, so actual value at t equals 40. That's going to be 5.32. And then we're going to subtract actual minus predicted y hat of 40. And that's going to be equal to, okay, well, what I'm going to do is actually I'll try to do that myself. 5.32 minus the answer. Okay, now I think on the new one you can just go highlight that number, but if you can't, that's how you would do that. Negative 0.065. Okay. Did our model underestimate or overestimate the total world population for the year 1990? Okay, remember what we said, in the lesson, kind of at the beginning, was it's kind of the opposite of what we expected. If we get a negative residual, that's actually because we had an overestimate. But if we look at the calculator, it's like, oh yeah, that does make sense because, the actual value is 5.32. We predicted 5.38. That was a little bit too high. That's an overestimate. Okay, so number 4. Okay, here's a residual plot. That's inappropriate, right? I just see it immediately. There's a clear pattern, so it's not appropriate because the residuals do show a quadratic pattern, okay? The fact that it's quadratic pattern in a quadratic regression is just a coincidence. That doesn't really have anything to do with what we're talking about here. It's if you see any pattern at all on any residual plot for any regression, that regression is going to be inappropriate. Is the message in AP Pre-Cal, at least. So a regression model was created for the data in the graph at left. Then the residual plot is given at right. Which of the following statements about the regression model is best? I don't like the look of it because we've got a clear up down up pattern in the residuals. So how would I know that? I'm not sure how I would know which. Okay, I feel like the model is inappropriate. Oh, there's more to this question than I would have thought. Okay, so I'm going to, not that it's really that big of a deal, but I'm going to get rid of answer choices A and C. All right, I think the idea is, I can see that the data are clearly exponential because they're not going down and up, they're just only increasing. There has to be something I'm not seeing about the nature of a quadratic. Okay. Oh, maybe it's the overestimate because of a negative residual, underestimate through here, overestimate, underestimate. Okay, if we got rid of those, we went from overestimating to underestimating to overestimating to underestimating. Estimating to underestimating to overestimating. I don't know. I recognize there might be something I am not seeing on this example, and if you do see, like, either let me know in the comment or like come and tell me before school, because I can see that based on the data, an exponential regression would definitely be appropriate. Who I don't know. Well, we'll see. A times b to the x. Well, I could need a plus c or something. I don't know. That one has left me a little confused. We'll have to consult with the other teachers on that one. Okay, linear regression, I'm seeing a pattern. Quadratic regression, yet another pattern. Exponential regression, pretty much scatter. So I like the exponential model, okay, because I'm seeing no pattern here. So I think that it's probably an exponential equation that would best model the data. Residual plot, this again is pretty random scatter. Got a quadratic regression model. Which of the following conclusions is correct? No apparent pattern, so yes, it's appropriate. Yeah, there we go. Okay, and that's all we've got. Yep, this is a nice short homework. There's really not that much you need to know about residuals. I'm definitely going to be thinking about this multiple choice question over here. What if it was truly quadratic? Just had a really close to zero value of a. Let me think about that. And we'd used an exponential model. Overestimates it. I'm stuck on this. I don't know how either of these things are possible. To be honest with you, but that's gonna be all for this video. Thanks for watching.